Assalamualaikum warahmatullahi wabarakatuh. Hari ini grup saya, kami grup 4. Kami akan bentangkan tentang assignment kami dan nama saya Nur Fizani Izzati binti Rosni bersama dengan ahli kumpulan saya Wan Muhammad Afiq, Rajin Nasional dan Muhammad Amir Izari. Kami akan bentangkan soalan kami untuk grup assignment kami untuk subjek fizik di EKA 1113. Dan untuk soalan yang kami pilih untuk grup assignment ni ada terdiri daripada beberapa chapter iaitu rotational motion, Newton's law of motion, linear momentum, conservation of energy dan juga kinematics. Dan ini adalah soalan yang kami pilih. Soalannya adalah a bowling ball of mass 6 kg is released from rest from the top of a slanted roof that is 4 meter long and angled at 30 degrees as shown above. The ball rolls along the roof without slipping. The rotational inertia of a sphere of mass m and radius r about center of mass is 2/5 mr to the power of 2. Jadi berdasarkan soalan kita dapat mass untuk bola adalah 6 kg dan juga inertia, rotational inertia untuk bola tersebut adalah 2/5 mr per second. Jadi kita akan mulakan dengan soalan yang pertama. Soalan pertama bunyi, on the figure below, draw and label the forces, not components, acting on the ball at their points of application as it rolls along the roof. Jadi untuk soalan ni dia menyuruh kita untuk labelkan force-force yang berlaku apabila bola ni jatuh rolls along the roof, bergolek sepanjang bumbung. Jadi dekat soalan, untuk jawapan soalan ni, dekat soalan ada beberapa clue yang kita boleh guna. Untuk yang pertama, along the roof. Ball as it rolls along the roof bermaksud permukaan bumbung dan juga permukaan bola bersentuhan. Jadi apabila ada sentuhan di situ akan berlakunya normal force. Normal force adalah force yang berlaku apabila ada kontak antara dua objek. Jadi untuk sini bola dan juga bumbung mempunyai kontak antara satu sama lain. Jadi itu untuk force yang pertama. Jadi untuk force yang kedua adalah gravity. Sebab benda ni berlaku di atas muka bumi, kita gravity. Jadi untuk force yang kedua adalah gravity. Jadi force sama dengan Fg sama dengan mg. Untuk force yang kedua. Dan untuk force yang ketiga, kita boleh tengok balik pada soalan iaitu as it rolls along the roof. Maksudnya ada pergerakan di situ dan juga permukaan bumbung dan juga permukaan bola bergeser antara satu sama lain. Jadi adanya geseran di situ. Dan untuk force seterusnya adalah friction. Akan berlaku friction pada diagram untuk sini. Dan friction berlaku berlawanan dengan arah pergerakan bola.
My name is Muhammad Amir Izari bin Azizan. Now I will continue for part B. The question is, calculate the force due to friction acting on the ball as it rolls along the roof. If you need to draw anything other than what you have shown in part A to assist in the solution, use the space below. Do not add anything to the figure in part A. Okay, Fizani has drawn the diagram in the part A. Now I will discuss about I will calculate the force due to friction acting on the ball as it rolls along the roof. Okay, the force along the plane along the roof are the component of the weight along the roof, Fx, and here F is force of friction, and the equation F equals to ma is the basic equation. Okay, Fx minus Fi equals to mg sin theta minus Ff. Mg, mass and gravity, for the sin theta minus Ff, force of friction. And below we see torque equals to rotational inertia times angular acceleration, T equals to Ia. And below T equals to Ff. Other than that equation, I for rotational inertia, I equals to 2/5 mr square. Next, acceleration equals to angular acceleration times r. Angular acceleration equals to a minus a divided r. Fr Actually, torque is also F times R, where the force F that is making the ball spin as in contact with the incline is the frictional force. Okay, we at the equation we substitute F times R equals to IA. Okay, since the ball is spherical, we can replace with 2 over 5 mr2. R is radius, the formula for the moment of inertia. We can also replace A, since A equals to AR, where A is the tangent acceleration of the ball and R is the radius of the sphere. Okay, next in the equation below, FR equals to FR equals to I A over R. In the below, we in the equation 2 over 5 mr square times A over R, R square in the bracket and in the times A over R square, we can decline it. F equals to 2 over 5 MA. Okay, 5 over 2, we move to the next with 5 over 2 FF equals to mg sin theta minus FF. 7 over 2 FF equals to mg sin theta. Okay, if we solve for MA, we get okay, we move to the equation. FF equals to 2 over 5 mg sin theta, 2 over 7. Okay, we in the number m mass for the m 6 kilogram in kilogram. Next 9.8 for gravity, sin theta sin 30 degree, and the answer is egg for 6 Newton. Thank you. Now I pass to the next presenter.
Assalamualaikum, my name is Rajadesh Daniel, and now I'll be explaining the solution of C, which is calculate the linear speed of the center of mass of the ball when it reaches the bottom edge of the roof. So this question requires us to use the energy conservation concept, which energy that enters the object equals to energy that exits the object. So energy in also it refers to gravitational potential energy, and the energy out equals to the total kinetic energy plus the rotation kinetic energy. And then from gravitational potential energy, as we all know, it is mgh, and then the formula for the total kinetic energy is half mv squared, and rotational kinetic energy is half iw. Okay, from there we can see that each and every one of these formula contains an m, so we can just cut it out, and then after that it turns into gd sine theta equals to half v squared plus half times 2 over 5 r squared v over r squared. And then we can cut out the r to make the operation easier. So the last result after you calculate, you will get 5.34 meter per second.
Okay, saya Wan Afiq bin Zakaria akan menerangkan mengenai soalan D. A wagon containing a ball is at rest on the ground below the roof so that the ball falls a vertical distance of 3 meter and lands and sticks in the center of the box. The total mass of the wagon and the box is 12 kg. Calculate the horizontal speed of the wagon immediately after the ball lands in it. Jadi soalan ini menginginkan kita untuk mengira kelajuan horizontal wagon tersebut selepas bola mendarat di dalamnya, selepas jatuh daripada bumbung tersebut. Halaju horizontal bola tersebut selepas sahaja jatuh daripada bumbung tersebut ialah Vx sama dengan V cosine 30 darjah. Seperti yang anda dapat lihat di gambar tersebut. Bola tersebut akan mengekalkan laju horizontal dengan adanya horizontal acceleration. Laju inilah yang membuatkan wagon tersebut bergerak ke hadapan. Jadi soalan ini dapat diselesaikan dengan menggunakan formula daripada chapter linear momentum. The momentum before and after collision must be conserved. The main formula is P equal to mv. So we got P initial equal to P final. After we change, we got M1 V initial equal to M2 V final. The V initial we change into Vx, it will become M1 Vx equal to M2 V final. Substitute the Vx, we get M1 V cosine 30 degree equal to M2 Vf. We bring the M2 to the M1 V cosine 30 degree because we want to find the V final, which is the horizontal speed of the wagon. So it will become the M1 per M2 V cosine 30 degree equal to V final. We substitute the number, we get 6 kilogram per 18 kilogram times by 5.34 meter per second times by cosine 30 degree equal to V final. And the last answer we got is 1.54 meter per second. So that's all from us. Thank you. Assalamualaikum.